Let's talk about how large language models are developed. In this video, we start by providing a comparison between LLM development and traditional machine learning development. Then, we will talk about three main kinds of LLMs, and at the end, discuss a concept called chain of thought reasoning and how that can help with designing better prompts for LLMs. Let's kick things off by comparing the development of LLMs using pre existing models with the traditional approach of machine learning development. In the LLM world, there's no prerequisite for technical expertise or extensive training examples. And guess what? You can forget about model training too. It's all about the art of prompt design clear, concise, and full of useful information. On the other hand, traditional machine learning requires you to roll up your sleeves and dig deep into training examples, model training, and even sometimes needing a basic knowledge of hardware and computing power. There are three main types of LLMs: generic, instruction tuned, and dialogue tuned. Each of these models require its unique style of prompting. Generic language models work like your phone's autocomplete, predicting the next word based on the training data's linguistic patterns. Instruction tuned models, on the other hand, are responsive to specific directives. Whether it's summarizing a text, generating a poem in the style of a famous poet, or offering a sentiment analysis of a statement, these models follow the instructions embedded in the input. And lastly, we have dialogue tuned models. These are a subset of instruction tuned models specifically designed for interactive context, much like a chat with a bot. So let's dive into examples of these three kinds and see them in action. Before jumping into examples of different kinds of LLMs, let's provide a definition for tokens. A token is a unit of data that the model processes. It can be a word or part of a word. We'll begin with the generic language models. They're pretty straightforward. Their primary task is to predict the subsequent word based on the context provided by the training data. Let's take a simple example. The cat sat on, and now we want to know what the most probable next word is. And the model tells us the is that answer. Just like how your phone's autocomplete features would suggest. It's a fascinating glimpse into how AI can mimic the way we naturally communicate. Moving on to instruction tuned models. These models shine when it comes to generating responses. They take their cue from the instructions given in the input, whether it's a request to summarize a text, generate a poem in a particular style, or even classify a text sentiment. It's like having your very own digital assistant, always on standby to carry out your instructions precisely. And lastly, we have dialogue tuned models, which are a specialized type of instruction tuned models. However, they aren't just waiting for instructions, they're trained to engage in a back and forth conversation. You might typically encounter them in the form of chatbots. If you've ever asked a virtual assistant a question, it's likely you've interacted with this kind of model. It's all about enabling a natural conversational interaction. Now it's time to explore an interesting concept: the chain of thought reasoning. This is an observation that models are more accurate in producing correct answers when they first generate a reasoning pathway or chain leading to the answer. Let's consider a simple example. Roger has 5 tennis balls and buys two more cans, each with 3 balls. How many balls does Roger have now? Initially, the model might struggle to provide the correct answer. However, after presenting the problem a second time, the model becomes more likely to conclude with the correct answer. The chain of thought reasoning assists in enhancing the understanding and response capabilities of large language models. In conclusion, the development and deployment of large language models open up exciting new avenues in the world of machine learning. As we continue to improve and refine these technologies, we anticipate a future where advanced language comprehension by AI drastically changes our interaction with digital platforms. Now that we understand how LLMs are developed, it's time to see why tuning them for specific tasks is important and how we can tune LLMs in an efficient way. See you in the next video.